Hi everyone. Today I'm going to present the solution to example 4 by double integration method computing deflection and slopes. So compute the slope and deflection at points A, C, and F. EI is constant. So solve by double integration. So first, let's look at the figure. So if we consider if we section the last segment of the beam, then everything is continuous. So there's nothing to modify the loadings in the B. So let's solve for the reactions at B and E. Let's call that RB and RE. So summation of moment about E equals 0, considering clockwise as positive. So clockwise moment equals counterclockwise moment. So R sub B times 10 then equals 20 times 11.5 plus 180 plus 30 times 5 times 0.5. So solving for R sub B is 48.5 kilonewtons, so it's upward as indicated in the figure. Summation moment about B equals 0, counterclockwise as positive this time. So we have counterclockwise moment equals clockwise moment. So RE times 10 plus 20 times 1.5 plus 180 then equals clockwise moment 30 times 5, then the moment arm is, because this is 0.5, so 10 minus 0.5 is 9.5, so 30 times 5 times 9.5. So solving for RE is 121.5 kilonewtons upward. Now we section EF, and the distance from the left end, let's call that X. So since we only have one equation of the elastic curve, differential equation of the elastic curve. So let's call that X from the left hand. So EI, Y double prime equals RB, which is 48.5 times X minus 1.5. So this distance from this section up to here is X minus 1.5. Then plus RE, which is 121.5, then this distance is x minus 11.5. So 121.5 minus x minus 11.5, then minus 20 times x, then minus 180 because 180 is not acting at the origin. So let's have its moment arm equal to x minus 4.5 to the 0. So this distance supposedly is x minus 4.5. Because this is already a couple, then we just make the power of x minus 4.5 raised to 0. Anyway, that is 1. And the main purpose of that is to make sure that when we compute for deflections and slopes, when we set values of x, remember that when the quantity inside this parenthesis is negative, we simply ignore that term. Then minus this distance is x minus 8.5. So 30 times x minus 8.5, then the moment arm x minus 8.5 over 2. So that becomes 15 times quantity x minus 8.5 squared. So that's the differential equation of the elastic curve. Then integrating once, EI y prime equals 24.25 x minus 1.5 squared plus 60.75 x minus 11.5 squared minus 10 x squared, integral of that, minus 180 x minus 4.5 raised to 1, or x minus 4.5, then divided by 3, minus 5 quantity x minus 8.5 cubed plus c sub 1. So that would be the equation for the slope at any point on the elastic curve. And integrating again, so we'll have 97 over 12 x minus 1.5 cubed plus 20.25 x minus 11 cubed, 11.5 quantity cube, minus 10 thirds x cubed, then minus 90 x minus 4.5 square, then minus 1.25 x minus 8.5 to the fourth plus c sub 1x plus c sub 2. So both c sub 1 and c sub 2 have values because a is not at the support. So c sub 1, remember, is the slope at a, then c sub 2 is the deflection at a. So let's call this equation 1, equation 2, then equation 3. So we substitute the boundary conditions. When x is 1.5, y is 0, and when x is 11.5, y is 0. So first, for x is 1.5 in equation 3. So when x is 1.5, so 0 equals 0 plus, ignore, minus 10 thirds 1.5 cube, ignore, plus c sub 1 times 1.5 plus c sub 2. So that would be the equation. Simplifying that equation, 1.5 c sub 1 plus c sub 2 equals 11.25. Call that equation A. Then when x is 11.5, y is 0. So still in equation 3. So 0 equals 97 over 12, 10 cube. Then this is 0. So minus 10 over 3, 11.5 cube. Minus 90 times 7 square, this is 7, minus 1.25 times 3 to the fourth, then plus c sub 1 times 11.5 plus c sub 2. So simplifying this equation, we have 11.5 c sub 1 plus c sub 2 equals 1497.5. So we can now solve the two equations simultaneously. You may subtract the two equations, so eliminate c sub 2 and solve for c sub 1, then substitute into equation A rather, and we can solve for c sub 2. So by doing that, c sub 1 equals 148.625 and c sub 2 is equal to negative 211.6875. So remember, c sub 1 is theta A, so divided by EI. So 148.625 over EI, and delta A is negative 211.6875 over EI. So you may express your answer as 148.6, round off to 4 significant figures, and negative 211.7 over EI for delta A. So next is at C. So x is 4.5. When x is 4.5, we can compute theta C and delta C. So in equation 2, 24.25 times 3 square, then ignore, minus 10 times 4.5 square, 0, then ignore, plus c sub 1, which is 148.625. So the theta C is equal to 164.375 over EI, and when x is 4.5 in equation 3, so we have 97 over 12 times 3 cubed, then ignore, minus 10 over 3 times 4.5 cubed, ignore, then plus c sub 1, which is 148.625 times 4.5, and plus c sub 2, which is negative 211.6875. So we can now compute delta C. Delta C is equal to 371.625 over EI, and it is positive. And next is when x is at F, when x is 13.5. So EI theta C in equation theta F in equation 2. So we have EI theta F equals 24.25 times 12 squared plus 60.75 times 2 squared minus 10 times 13.5 squared minus 180 times 9, then minus 5 times 5 cubed, and plus c sub 1, which is 148.625. So solving for theta F, it is equal to negative 183.875 over EI. Since we ran out of space, I will leave that calculation to you. You just substitute in equation 3, x is 13.5, and check that it is delta F is equal to, check this value, negative 347.75 over EI. So thanks for watching, and I hope that you continue to subscribe in my YouTube channel so that you will be updated with the lecture videos that I will have in the future. Then I hope that this video will help you improve your skills in computing deflections. Goodbye.